Hello everyone, and this is Devabrata here. Welcome to all of you to our channel Schrodinger's Cat. So we just, for your exam point of view, we just discuss here the chapter summary in a nutshell and the problem coming in NEET JEE Main Advanced. And after we cover all the topics, we just do the theory elaborately. And in our previous lecture, we had just discussed the properties of matter. This is the lecture of 8 of the Heat and Thermodynamics. So today we just cover here the thermal properties of matter, the thermometry and thermal expansion, specific heat, capacity, change of state and calorimetry, the heat transfers. Next one, the thermodynamics, zeroth and the first law, thermodynamic state variable and thermodynamic process, kinetic theory of gases, that the kinetic theory of gases and the gases law, the degree of freedoms and the laws of equipartition of energy, specific heat capacity and mean free path. And the number of questions coming in the NEET exam, 3 or 4, this is a main topic, and the JEE Advanced 4 and 5, JEE Main and the JEE Advanced 4 questions are coming in this chapter. So this is very important and the unique topic in your NEET and JEE Main physics. So let's get started. So first of all, we just discuss here the kinetic theory of gases. We just draw a line for a better understanding and clarifications of this board. So that the kinetic theory of gases, the ideal gas equation that states that PV equal to nRT, that here we just write PV equal to nRT and the gas constant R equal to 8.31. This is in Joule per mole Kelvin. The pressure of the ideal gas, that P, the pressure of the ideal gas, 1/3 rho V bar square, and the pressure, that the 2/3 E of total energy, where the E be the half rho V average square, the kinetic energy per unit volume. Next one, that the root mean square velocity VRMS is equal to root over 3RT divided by M. So VRMS is proportional to root over of T. And at temperature T, for two gases of weight M1 and M2, that V1 RMS divided by V2 RMS is equal to root over of M2 by M1. And the average kinetic energy of ideal gas molecule, that the E equal to half mv square V average square, and the V average square is equal to 3RT by M. So E equal to, just put this value, 3 by 2 RT. And kinetic energy of one molecule, this is for the 1 gram mole and for one molecule E would become 3 by 2 kT, where the K is equal to R by N. This is called the Boltzmann constant. Boltzmann constant. And the next one, that the average speed V average is root over 8 kT by pi m is equal to 8 RT by pi m naught, where m naught be the molecular weight is written as m times Avogadro number, and the most probable speed, that Vp is equal to root over 2 kT by m, and this is equal to root over 2 RT by m naught. And next one, the Boyle's law, P is proportional to 1 by V, or PV is equal to constant. And the Charles law, V is proportional to T, and thus imply P is constant. The next one, Van der Waals equation for real gas, that the P plus A by V square into V minus V equal to RT. This is for 1 mole. And next one, the Graham's law of diffusion. Graham's law of diffusion, that rate of diffusion of two gases be the R1 and R2 of density ρ1 and ρ2 is defined as R1 by R2 is equal to root over ρ2 by ρ1. Basically, the R is proportional to root over of ρ, inverse of R proportional to inverse of 1 by ρ. So next one, that the calorimetry and the thermal expansion. Calorimetry and the thermal expansion. So that here the specific heat capacity or specific heat is written H S equal to H by M into del theta, and the unit calorie into Kelvin. And the next one, the heat required to raise temperature theta 1 to theta 2, the Q equal to ms del theta, or S be the Q by m del theta. Heat required during change of phase, Q equal to ml. Next one, specific heat, that for water 1 calorie per gram degree Celsius is equal to 4.2 kilojoule per kg degree Celsius. And the latent heat of vaporization, that the L is equal to H by M is equal to 540 calorie per gram. And the latent heat of fusion, this is for vaporization V, and the latent heat of fusion that H by M is equal to 80 calorie per gram. You just know this value. And next one, that the thermal expansion. That the coefficient of linear expansion alpha is equal to 1 by L del T. At del T tends to 0, that alpha is equal to limit del T tends to 0, 1 by L del L by del T is written as del transferred to derivative differential dl dt. At del T tends to 0, alpha would become 1 by L dl dt. And suppose the length of rod is L0 at 0 degree Celsius and L theta at temperature theta, then alpha would become that the L theta minus L0 divided by L theta minus L0 divided by L0 theta, or L theta is equal to L0 1 plus alpha theta. Next one is the beta, coefficient of area expansion, that written as 1 by A dA dt. Next one, coefficient of volume expansion, that the gamma 1 by V dV dt. Here the alpha, I just write 1 against 1 by L dl dt. So the relation between the alpha, beta and gamma, that the alpha is to beta is to gamma is equal to 1 is to 2 is to 3. So next one, go ahead, our thermodynamics. So that the thermodynamics work done by a thermodynamic system. So this is a system where is P and the V. This is the V1 and the V2. So the work done del W is equal to P into del V. When pressure is variable, that region at dW PdV. Basically the W V1 to V2 PdV. Basically the area of the curve, that the ABCD. This is A, B and the C and the D here. So next one, that the first law of thermodynamics that tells that Q is equal to del U plus W, or the del U change of internal energy is Q minus W. So W is equal to area of closed loop. W is equal to area of closed loop. And the next one, that if the work done by the system will be positive, very important theory, work done by the system is positive when this is in the clockwise directions. Suppose these directions, this is PV graph, and work done is negative when this will be the anti-clockwise. Suppose this is P and the V here, this is triangle with the anti-clockwise, this one. Here the del W is positive, here del W is negative. Next one, that the cyclic process that del U is equal to 0. So del U equal to Q minus W, or Q equal to W. The next, isolated. For the isolated system, that Q equal to W equal to 0 for the isolate. So del U equal to Q minus W, or del U is equal to 0 for the isolated system. Next one, the isobaric process. So in the isobaric process, that the W equal to P into del V. So ANR T2 minus T1. So next one, that the isochoric process. In the isochoric process, del V is equal to 0. So work done W P into del V, that would be 0. And from the first law of thermodynamics, that del U equal to Q minus 0. So Q would be del U. Next one, that the isothermal process, that the del U equal to 0. So you would get the Q equal to W, and the P1 V1 equal to P2 V2, or V2 by V1 is equal to P1 by P2. And the work done here for the isothermal process, that nRT ln P1 by P2, or nRT ln V2 by V1. So for one thing is that for log base E to log base 10, you just convert, multiply with 2.302 log 10. This is the natural logarithm and the Napoleon logarithm. Just convert with multiply the 2.303. You just do in mathematics. Next one, the adiabatic process. In the adiabatic process, Q equal to 0, that the del U equal to minus W, and here the P V to the power gamma equal to constant. The gamma be the ratio of Cp by Cv. So T V to the power gamma minus 1 should be constant, and T to the power gamma by T to the power gamma divided by P to the power gamma minus 1 should be constant. These three. And the work done here for the adiabatic process, that the 1 by gamma minus 1 P1 V1 minus P2 V2, it should be written in the form of, for the n mole, that nr divided by gamma minus 1 the T1 minus T2, these two forms. The adiabatic process work done. Next one, the specific heat capacity of the gas. Go ahead. That the specific heat capacity of the gas. So the specific heat C is defined the Q by m into del theta. Molar heat capacity at constant volume is Cv and at constant pressure is Cp, and the ratio of the specific heat gamma is Cp by Cv, and the relation between Cv and the U is del U equal to n Cv del T, and specific heat of gas mixture, that the Cv for the gas mixture, that N1 Cv1 plus N2 Cv2 divided by N1 plus N2, and the Cp would become N1 Cp1 plus N2 Cp2 divided by N1 plus N2. Next one here gamma, that the ratio of Cp by Cv would become here in this case N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. Next one, this is the Mayer's formula. That states that the Cp minus Cv is equal to R. Mayer's formula. And next one, formula for internal energy. So internal energy U, that N half FKT is written as the half FRT, where the F be the half FRT, where the F be the degree of freedom, F be the degree of freedom, and here the Cv, that the half Fr, and Cp F by 2 plus 1, F by 2 plus 1 into R, and here the gamma, the ratio, the Cp by Cv would become, just put this value, F by 2, F by 2 plus 1 into R, Cp value, and the Cp value, the F by 2 into R. This would become 1 plus 2 by F. This is very important. The R equal to 1 plus 2 by F. Next one, that for monoatomic gas has only 3 translational degree of freedom. So for monoatomic, that the F is 3. So U equal to 3 by 2 RT. For monoatomic gas, that Cv 3 by 2 R, and the Cp 5 by 2 R, and the gamma here Cp by Cv, that 5 by 3, 1.67. Next one, for the diatomic. For the diatomic gas molecule, that F equal to 5, because 3 translational and 2 rotational. For that case, U would become 5 by 2 RT and CV 5 by 2 R, CP 7 by 2 R, just R plus, thus CP minus CP equal to R. So 7 by 2 R. So gamma here, that the CP by CV would become 7 by 5, so 1.40. And next one be thermodynamics heat engine. Suppose this is a heat engine and this is the Q2 heat rejected and Q1, this be the Q1 heat supplied and this W is work done. So in that process W equal to Q2 minus Q1 and the efficiency eta would become W by Q1 is equal to 1 minus Q2 by Q1. Next one, efficiency of Carnot engine. So efficiency of Carnot engine, that become this one, the PV graph. So PV, this is origin and here the temperature T1 and T2. So this is adiabatic and this is isothermal. Adiabatic, isothermal, this is adiabatic and this is the isothermal. So here the efficiency eta dash, that the 1 minus Q2 divided by Q1, that would become 1 minus T2 by T1. And the Carnot theorem states that Carnot's theorem that eta would 1 minus T2 by T1, that can be maximum efficiency of heat engine. This is the Carnot's theorem. And last one, the entropy, that the del S is equal to del Q divided by T. This is the entropy formula. Del S is equal to del Q divided by T. Go ahead our next discussion, that the heat conduction. So in the heat conduction, first one, the heat transfer. So heat transfer, suppose heat transfers that the L distance, this is area A, here turns T1 and T2, this is X, elementary dx with the dt where T1 is greater than T2. So heat current dq dt, heat current is equal to minus Ka dt dx. So del q by del t would become Ka T2 minus T1, sorry, T1 is greater than T2, so T1 minus T2 divided by L, where K is the thermal conductivity of the material, K the thermal conductivity. So next one, the thermal resistance. So the thermal resistance R theta is defined as the L by K. This is called the thermal resistance, and the I heat is equal to Q by T. Just put this value del T by L by Ka. So finally I heat would become del T by RT. RT be the thermal resistance. Comparing with I, we just know del V by R by Ohm's law. So at del T, T2 minus T1 similar to del V, that V2 minus V1. So RT would become 1 by K L by A, similar to R equal to rho L by A. And we just discussed in the current electricity chapter. So RT is equal to 1 by K L by A. Very important relation. Next, go ahead, that the series and parallel combination of the rod. Suppose This is K1 thermal conductivity and K2. These combinations questions are coming in your JEE advanced type questions. T1, T2, and this is area A1 and the A2. Here length L1 and the L2 same as this one. In your resistance, here R1, that the L1 by K1 A1, and R2, that L2 by K2 A2. This formula we just apply. So R equivalent, that R1 plus R2 in series. So equivalent thermal resistance would become that the R1 plus R2 plus dot dot plus Rn. Next one, the parallel combinations. So in parallel combinations, that this is the K1 K2, here the T1, here the T2, this is for A1, this is for A2, this is length L. So the similar as this one, this similar as this one. So here just R1 L by K1 A1, R2 equal to L by K2 A2. So we just know 1 by R parallel equal to 1 by R1 plus 1 by R2, just put this value. So this type of in parallel combinations. Next one, that the Kirchhoff's law in thermodynamics or heat transfers. So this is a del A, suppose del A cross sectional area, and this is the del omega, basically the solid angle. So emissive power E would become del U divided by del A in unit solid angle del omega at unit time del T. So del A is area, del T is time, del omega is solid angle, and del U, this is energy radiated. Del U, the energy radiated. So absorptive power alpha is energy absorbed by energy incident, and the Kirchhoff's law here states that, I just write here, Kirchhoff's law states that the energy of body divided by A of body is equal to energy of black body, and here A be the absorptive power. Next one, the Wien's displacement law. The Wien's displacement law states that the lambda mt is equal to B, where B is the Wien constant and the value is 0.288 semi K. Next one, the Stefan-Boltzmann law. Go ahead. Our next discussions, that the Stefan-Boltzmann law, that U equal to sigma A T to the power 4. Sigma is a Stefan constant and T be the temperature for a body which is not black body, that U E sigma A T to the power 4. This is not for black body, so del U would become E sigma A T to the power 4 minus T0 to the power 4 is not net loss of thermal energy per unit. This is the net loss of thermal energy per unit time. So next one, the Newton's law of cooling. The rate of cooling of a body is directly proportional difference between absolute and the supporting temperature and the surface area of the temperature exposed. It's defined as the dt is minus BA T minus T naught, where A be the surface area and B is a constant and T is absolute temperature. This T is absolute temperature and this T naught is surrounding temperature. Surrounding temperature, and this is the absolute temperature. This is the Newton law of cooling. And this one, the Stefan-Boltzmann law. So we just cover here in our theory discussion sessions, and now we just switched on to a lecture to the problem discussions. So first of the problem coming in JEE Main 2019, two material having coefficients of the thermal conductivity 3K and K of thickness D and 3D in this form. You have to find the temperature at the interface. This interface you have to find the temperature. Let us say this temperature is theta. You have to find this. So rate of heat flow the first slab is equal to rate of heat flow in the second slab. So just put this formula 3K we just discussed in your chapter summary session. Theta 1 theta 2 minus theta 1 divided by D is equal to K A theta minus theta 1 divided by 3D. Just solve this. 9 theta 2 minus theta 1 equal to theta minus theta 1. So 9 theta 2 plus theta 1 is equal to 10 theta, or the theta would become 9 by 10 theta 2 plus 1 by 10 theta 1. Simple. So I think D would be a correct answers. 9 theta 2 by 10 plus theta 1 by 10. D would be a correct answers. Go ahead. Our next JEE Main 2024 PV diagram of an ideal gas having three different density rho 1, rho 2 and rho 3. Which is the correct? So this is for P1, this is for P2 and this is for the P3. So PV equal to nRT equal to M by mRT is equal to that the M by V here RT by M. So P equal to rho RT by M. So P equal to rho RT by M is P proportional to rho, that P1 is greater than P2 is greater than P3. So in this condition that rho 1 should be rho 2 greater than rho 3. So our final rho 1 greater than rho 2, rho 1 greater than rho 2, D would be our answer. Just common sense applied here. Next one, NEET. Sorry, this question is coming from the JEE Advanced 2021, recent type of question, very important questions. 2 times it has come that the ideal gas undergoes 4 steps in the PV diagram. During the cycle, heat is absorbed by the gas is what will be the correct? This one 1, 2, 3, 4. So this is process 1. Process 1. For the process 1, that the W is PdV and the change of internal energy that F by 2 nR del T. I just write in your chapter summary in a nutshell. So you have to find heat is absorbed by the gas in which section. Heat is absorbed, this is important. Heat is absorbed or rejected. So here the W greater than 0, positive. So Q is absorbed. Here Q is absorbed here. Process 2. Here this process P proportional to T. So W is equal to P dV. This is 0. And it's change in internal energy, that the F by 2 nR del T. From the first law of thermodynamics, the del Q equal to del U plus W. So del Q less than 0. So here heat is rejected in this process. The process 3, here should be W equal to P del V. So negative 0. Del U equal to F by 2 nR del T. Negative 0. Negative, and the del Q W plus del U by the first law of thermodynamics, this is less than 0. So here rejected. Heat is rejected. Process 4, this is 4 to 1, that the W here 0, del U greater than 0, del Q is also greater than 0. So here heat is absorbed. Heat is absorbed. So heat is absorbed in the when steps. So C would be our correct answer. Step 1 and 4. This step 1 and the 4. Step 1 and the 4. These two process absorbed. So C would be our correct answer. Steps 1 and 4 would be heat is absorbed by the gas. Go ahead, our next problem, that coming in 2014 NEET exam, saying that a thermodynamic system undergoes cyclic process A, B, C, D, A. So work done, you have to find the work done. So you just know the work done equal to area under the curve, that the area half base height minus basically the del W is W1 minus W2 minus half V0 P0, that would be 0. And one thing is cyclic process, so work done by the cyclic process should be 0. So the D would be our correct answers. Go ahead, our last problem, NEET 2024, the recent questions, that 2021, the recent question and the match type of questions. These are also coming in the NEET exam also. And JEE Advanced part 3, matching type of questions and the statement type. So match column 1 with 2. Column 1, root mean squares gas, pressure exerted by ideal gas, average kinetic energy of a molecule, total internal energy of diatomic molecule. And we know that the VRMS, that the 3RT by M, and the P, that 1/3 rho C square. 1/3 rho means N M V average square, and the kinetic energy average, that 3 by 2 kBT, and the F is 5 degree of freedom. So del U is equal to NF RT by 2. So del U equal to 5 RT by 2. So I think root mean square speed would become 2. This one. Pressure exerted by ideal gas would be this one, 1/3 rho C square, that the Nm V average square. Next one, average kinetic energy of a molecule. Average kinetic energy of a molecule, that 3 by 2 kT. We just know in your equipartition of energy. Total internal energy of 1 mole of diabatic molecule is 5 by 2 RT. So C would be our correct answers. A2 B1, that A2 B1 C4 D C. So we just cover here the 5 important questions coming in NEET JEE Main and Advanced. And for your better understandings and conceptual clearance, I usually give you the 5 another questions. You just pause this video and take a screenshot quickly. So I think you just take a screenshot of this problem, and we just cover here 10 important questions from the chapter Heat and Thermodynamics. So after doing this problem, you just mail with this ID catschrodingers1935@gmail.com and solve this homework. And if anyone needs this file and the study material, just mail without no hesitation with this ID. So last but not the least, thank you very much. Stay well and happy. Have a good day.